in the first one, here we have AB. It is a rigid bar. Rigid bar means whatever forces we are applying on this, it should not deform. Okay, with these forces or with this type of loads. That's it is calling rigid bar. Okay, so all machine objects we are assuming those are the rigid objects or rigid bar. And then here neglecting the weight of the bar. The weight of the bar is W is equal to 0. So means it has very less weight. And here we are taking this at alpha angle to this wall. Okay, here at A there is a hinged support. Here we are keeping one weight. Okay, one bar it has. The name is Q, and it is connected with that string DC. Okay, this is the string. Now total length of the bar is L. Okay, at the C means half of this A, L by 2. This is L by 2. We are connecting here. Here what we have to find? Tensile force produced in the string. We have to find the tension in this string or tensile force in the string because of this load. Okay, let us do the FBD diagram, free body diagram, like this. Okay, same length bar. Now here what I am doing means, C at the half of this I am taking some S. Okay, tensile force is acting here. I am taking S. Okay, at B what type of force? It is the vertical load I am taking, that is Q I am taking. Okay, and this angle is alpha. Here at hinged support there are two forces acting. One is horizontal force, one is vertical force, like this. So assume like this bar we can call this as the free body diagram, because free body diagram is we are removing the contact bodies. Instead of that we are taking the reactions with these objects or with these walls. Okay, we are removing the supports, we are giving the reactions because of those supports. It is called FBD. Now in it I am marking the points A, this is C, this is B. Okay, here I am considering three forces. Sigma FH is 0, sigma FE is 0, and sigma M is 0. As in case of beams also we are following these three conditions for getting the given object in equilibrium. So if I take the first one, what are the horizontal forces? FH and then S. There are two forces. So I am writing FH. This side I am taking positive and this side I am taking negative. Okay. Now FH is in this direction, S is in this direction, reverse direction. Whatever horizontal force, it is equal to tension in the string. We have to find this S value in the given problem. Take the next equation. Sigma FE is 0. What are the vertical components? FV and Q. Okay. So upward forces I am taking positive. Downward forces I am taking negative. Okay. Now take the upward force FE minus Q, because it is downward, minus Q is equal to 0. FE is equal to Q. Now with FH, first equation, sigma FH, we got this. With sigma FV, we got this. The meaning is, whatever vertical component here, that is equal to... Take the third condition, sigma M is 0. I am taking about A point all the moments because of these forces. So about A point, sigma MA is 0. For clockwise, I am taking positive. For anti-clockwise, I am taking negative. Here, moment is coming because of this force, anti-clockwise. Horizontal force, for horizontal force, we need to consider the vertical distance. We have to find this vertical distance. S into this V value. Let us take V1. I am taking. Okay, it is anti-clockwise. For anti-clockwise, I am taking negative. S into with minus V1. Next is Q force about A point. Q is vertical force. We have to consider this horizontal distance. Okay, this Q is coming like this here. Q into this horizontal distance. I am taking this is some H1. Okay, let us take. Q into H1, in which direction it is moving? It is moving clockwise. Plus Q into H1. Okay, is equal to 0. Because there are no other forces. We are taking about the A point. At A point, we are not about these forces, we are not taking moments, because perpendicular distance is 0 for these forces, because those are acting at the same point. Now we got this equation. In it, we have to find S value. Okay, tensile force in the string. S means. Now here, from this equation, we can remove this minus by equating to SV1 is equal to QH1. S is equal to, here we can write like this, S is equal to QH1 by V1. Okay, like this we can write. Now here we had to find H1 value and V1 value by using this right angle triangles. V1 we can find by using the smaller triangle. H1 we can use by using the bigger right angle triangle. Now how to find, let us see. Now here for the smaller one I am taking this triangle. The given angle is alpha, like this. The remaining angle is 90 minus alpha. Okay, because total angle is 90, alpha is given, 90 minus alpha. This length is L by 2. Okay, it is given. In this vertical height we can apply sine 90 minus alpha is equal to, vertical height is V1, this is L by 2, V1 by L by 2. Okay, so in it how to find V1? V1 is equal to L by 2 sine 90 minus alpha. So L by 2, what is sine 90 minus alpha? It is cos alpha. Okay, instead of V1 we can substitute L by 2 cos alpha. Similarly for finding H1, so we can take the bigger triangle like this. So for H1 we can apply cos. So cos 90 minus alpha is equal to H1, this is the H1. H1 divided by, what is the total length? L by 2 plus L by 2 means L. Total length is L. We need to find H1. H1 is equal to L into cos 90 minus alpha means L sin alpha. Now substitute H1 and V1 in this equation. We will get the answer Q into Q as it is. What is H1 here? L sin alpha. What is V1 value? L by 2 cos alpha. L by 2 means 2 is coming here, L by 2 cos alpha. L and L will be cancelled. What we are getting? 2Q sin alpha by cos alpha means tan alpha. S is equal to. So this is S is equal to 2Q tan alpha. This is the answer, final answer. It is the tension or tensile force in the string, in this string. Okay, in terms of Q.